In this presentation, we're just quickly going to look at how to check the critical value for a chi-squared test for independence. So, just as a quick remark, the chi-squared is written like this. This is a Greek letter chi, and we square it. And we might put in the subscript critical value just to sort of say it's a critical value to as opposed to the test statistic. So essentially what we have to do is we'll go to a question that I had a look at earlier on. Okay, so this is a question I did in a different presentation. I'll just put it into shot here. So we have the observed and expected there, but essentially what we're looking at here is the number of rows and number of columns. So I'll just sort of use the observed here. Essentially we have 3 rows, okay. We don't include the bottom, the row for the totals, so that's not included. So we're going to say R is equal to 3. Okay, R is our number of rows. Okay, and let's go back there. The number of columns we have is we have 2 columns for the levels of the categorical variable or the possible values A and B. So there's 2 columns there. So we're going to say C is equal to 2. Now, let's say, for argument's sake, we're dealing with a significance level of 0.05. So our alpha is 0.05. That's an important part first off. So what we're going to do here is go to our tables, and this is just some a rough sketch I've done. Essentially what we're going to do is go to our tables, and we're going to go to the column 0.05, because that's our significance level. So that's the column, okay? So far so good. The next thing we're going to do is go and find our degrees of freedom. So the rows are essentially tell us the degrees of freedom. And for this example, the degrees of freedom is R minus 1 times C minus 1. So R minus 1 times C minus 1. Okay. And in this case, that's 3 minus 1 times 2 minus 1. Okay. 3 minus 1 is 2. 2 minus 1 is 1. So what we have there essentially is, I don't have any room here. So essentially I just write that the degrees of freedom here is 2. Okay. So the degrees of freedom is 2 down here. That's the degrees of freedom. The row minus 1 times the column minus 1. Okay. So what we'll do here is go to our tables again, and essentially we're going to use this row here. Okay, so it's this column here and this row here. So the critical value essentially for this particular example is 5.99. In some books it might be given to 3 decimal places as 5.991. Not particularly important, but anyway, that is how you find the critical value for a chi-square test. So it's R minus 1. I'll just do this here in green just to remind us. R minus 1. It's not good. R minus 1. There we go. Times C minus 1 is the row, and alpha up here is the column. Okay, so that's it.